This is a rather complicated problem having to do with the stoichiometry of gases. Ammonia and hydrogen chloride gases react to form solid ammonium chloride. 10-liter reaction flask contains ammonia at 4.52 atmosphere and 22 degrees Celsius, and 155 milliliters of hydrogen chloride gas at 7.5 atmospheres and 271 Kelvin is introduced. After the reaction occurs and the temperature returns to 22 degrees Celsius, what's the pressure inside the flask? So let's look first at the reaction. Ammonia gas plus hydrogen chloride gas goes to ammonium chloride solid. Now we are given amounts of ammonia and amounts of hydrogen chloride, but it's not stated that these are stoichiometric amounts. So this is a limiting reactant problem, and we have to find out which reactant is limiting. And this is relatively easy since it's a one-to-one reaction. We only have to determine the number of moles of each, and the one with the smaller number of moles will be limiting. Now the next point is, after we determine the limiting reactant, we will observe that whichever reactant that is, all of that reactant will be consumed, and any excess reactant of the other reactant, the reactant in a 1-to-1 molar ratio, any excess of the non-limiting reactant, we'll call it, will still be present in the flask after the reaction, and it will exert some pressure. So let's first of all look at the number of moles of ammonia that we have. First of all, the ammonia is in the 10-liter flask, so the volume of the ammonia is 10 liters. The pressure of the ammonia is 0.452 atmospheres. And the temperature is 22 degrees Celsius plus 273 equals 295 kelvins. Okay. Now, from this, we can use N is equal to PV over RT, and we have the pressure in atmospheres. So this is 0.452 atmospheres times the volume in liters. It's 10 liters divided by the universal gas constant. I'm leaving units out here because I don't have very much room on this slide. And 295 kelvins. And when we carry out that calculation, with the proper units, of course, present, we find that the number of moles of ammonia is 0.187 moles of NH3. If we do the same thing for hydrogen chloride, the volume is 155 milliliters, and we can see by inspection that is 0.155 liters. The pressure is 7.50 atmospheres, and the temperature is given as 271 kelvins. In the same way, we can calculate the number of moles of HCl, and when we do that, we find out that 0.052 moles of HCl are present. So, if we look at the reaction, we have 0.187 moles of NH3. We have 0.06 sorry, 5, let me erase that. Zero 0.052 moles of HCl. So HCl is limiting, okay? And therefore, all of it will be consumed when the reaction goes to form ammonium chloride, and 0.52 moles of HCl will produce 0.052 moles of ammonium chloride. And that will leave 1.87 minus 0.052 is 0.135 moles of NH3 left over. Okay, so we've taken advantage of the stoichiometry of the reaction. We've calculated the number of moles of ammonia and the number of moles of HCl. We found out the number of moles of HCl is smaller, therefore it's limiting and will be all consumed, and there will be 0.135 moles of ammonia that remain after the reaction is over. Now the question is, what will be the pressure of the ammonia after the reaction is over? The pressure of the ammonia will be nRT over V. N is the number of moles left over, 0.135. Again, I'm going to leave out the units because I don't have much room here. 0.0821. And the problem says the temperature returns to 22 degrees Celsius, which is 295 kelvins. Divided by the volume, and the volume of the flask is still 10 liters. Notice it says to neglect the volume of any of the solid product, which would be very small. So this pressure, when we have calculated it here, turns out to be 0.327 atmospheres, and this is of ammonia gas. This is complicated, but if you take it step by step, each step is relatively easy. Let's review them. We have, first of all, the calculation of the number of moles of ammonia, 0.187 moles of ammonia. Then we have the calculation of the number of moles of HCl, which is 0.052. Then we have the recognition that HCl is limiting, and that after HCl is all consumed, there will be 0.135 moles of ammonia left over. Then we take that number of moles of ammonia in the 10-liter flask at 22 degrees Celsius, and we calculate the pressure at 0.327 atmospheres.